In this video, we're going to talk about how to identify an inequality. So let's start with the inequality x is greater than 3. And let's go ahead and write down in words what that means, because sometimes it can be easy to get them mixed up. Even if you know what the symbol means, just knowing the order. So how to say that in words, you would say x is greater than 3. Okay. And now the question is, which numbers make that true? I'll give us some choices. So let's pick 0, 1, 3, 5, and 10. Do any of those numbers make the inequality true? Do all of them make it true? Well, we could test out each one. Normally you wouldn't write this all out, but we'll do it this time just for fun. So we could say, is 0 greater than 3? No. Is 1 greater than 3? No. Is 3 greater than 3? No, 3 is itself. It's not greater than itself. Is 5 greater than 3? Yes. And is 10 greater than 3? Also yes. Are there any other numbers that would make it true? Absolutely. And last time we made a graph of all of those numbers. So let's do it again just for this example. So it doesn't really matter which numbers you put on your number line as long as you include the boundary point, which is the number that's in the inequality. So 3 itself was not a variable, or was not a solution. So I need to put an open dot, but everything bigger than it was. So now I'm going to do my arrow going up. So that means that both 3 and 10 are solutions to the inequality, and everything greater than 3 is as well. All numbers greater than 3 are solutions to the inequality. Now, this time, let's say that 10 is greater than x. That looks weird. Got things backwards now. Let's write that out. 10 is greater than x. What would that mean? And this time, I'm giving us 3 numbers to pick from. We're going to use 9.5, 10, and 10.5. So once again, let's sort of think this through with those numbers. And don't be afraid to write it out if that helps you think about it. So is 10 greater than 9.5? 10 greater than 9.5? Yes, that works. Is 10 greater than 10? No. Is 10 greater than 10.5? No. So that's the only one that works from our list. Is that the only one in general? Definitely not. 10 is also greater than 0. It's greater than 5. It's greater than 9.9. It's greater than 9.9999. Interesting. And if we wanted, we could even turn this inequality around and write it the other way. We could say x is less than 10, because those statements are the same thing. 10 is greater than x is the same as x is less than 10. Make sure you have both of those written down. Okay? And then when we graph it, we're going to show that at 10, we have an open dot, and we need all the values less than 10, because 10 is greater than x. So we're going down. Now let's look at a different example. Now let's say we're interested in which values satisfy both these inequalities. We're going to say x is greater than 4 and x is less than 9. And it's the same x. So we're saying x must be bigger than 4, but it also has to be less than 9. What numbers would work? Sorry, it has to be less than or equal to 9. Well, I know that 5 would work. 6 is bigger than 4 and less than or equal to 9. 7, 8, does 9 work? Yeah, because it has to be less than or equal to 9. Are there any other numbers that work? What about 4.1? Is that bigger than 4? Okay. How can I graph all these numbers at the same time? Let's try it. All right, so first, let's circle the 4, because it's greater than 4, but I'm not going to fill it in, because 4 itself does not work. And it's less than or equal to 9. So 9 does work, so I get to circle that one, or I get to fill that one in. And then we want all the inequalities that satisfy both. So I'm going to shade in between the two, like that. Nice. All right. This time, let's look at an example with negatives. I want you to copy down and then circle all the values that satisfy this inequality. Go ahead and pause until you've got it, and we'll talk about it, and then it'll be time for the practice problem. All right, so I purposely didn't read this aloud for you to make sure you had to puzzle through it. So we're saying x is less than or equal to -10. I always read them aloud to myself in my head. It really helps. X is less than or equal to -10. And so I need to know which numbers are less than -10. Well, -10, it's not less than it, but it is equal to, and that's allowed on this one, so that works. Is 0 less than -10? Well, in negative numbers, no, because negative numbers further away from 0 are smaller in the negatives. So no. -20, that's further away from 0. That works. -10.5, it's also further away. 3.4, that's even bigger than 0. That's all the way on the other side. That does not work. Okay, now it's time for the practice problem. Okay, so I've given you 1, 2, 3, 4, 5, 6 values that might satisfy this inequality. I want you to think carefully. I want you to copy this all down, and I want you to circle the ones that would work, the ones that are solutions, the ones that would satisfy this inequality.